Now, we are going to go through natural selection at the level of a population genetic in terms of L genotype and phenotype frequency. Natural selection can cause microevolution. Microevolution include change in L frequency, with fitness increasing, L's become more common in the population. Natural selection acts on an organism phenotype or observable feature. Phenotype is often largely a product of genotype, with the L's or gene version and the organism carriers. Fitness is a measure of how well organisms survive and reproduce, with emphasis on reproduce. Officially, fitness is defined as a number of offspring that organism with a particular genotype. Natural selection also can act on many traits controlled by many genes. In some cases, different phenotypes in a population are determined by one gene. For example, this was a case with hypothetical rabbit. It's also true in some. Natural selection can cause microevolution or change in L frequency over time. With fitness increase, L become more common in population over the generation. Besides that, natural selection can act on traits determined by the. Now we're going to proceed with the heterozygous advantage described in cases in which the heterozygous genotype have a higher relative fitness than either the homozygous dominant or homozygous recessive phenotype. The specific cases of heterozygous. Now we are going to proceed with the fitness. The first experiment confirmation of heterozygote advantage was with Drosophila melanogaster, a fruit fly that has been a model organism. Other than that, heterozygotes also give advantage in human genetics. Heterozygotes help in resistance to hepatitis C virus infection. There is evidence that genetic heterozygosity in human a variant of gene content a deletion render of shorter mRNA transcript that escape degradation by microRNA.